In this problem, we look at a spherical hailstone that's forming in the atmosphere. It starts from a piece of dust, so basically nothing, and the radius of the hailstone increases at 4 millimeters per hour. We want to find the rate at which the volume of the hailstone is increasing after 5 hours. Okay, so let's look at what we have here. We know that the radius is increasing at 4 millimeters per hour. So that means we know dr by dt. So dr by dt, that's the rate at which the radius is changing with respect to time, is equal to 4, and the units are millimeters per hour. We want to find the rate at which the volume is increasing, so that means we want to find out what dV by dt is. So dV by dt is equal to question mark at, and we always have to figure out at what point in time or at what moment for these kind of problems. It says here at the 5 hour mark, so at t equals 5 hours. Now, in this problem then, we are dealing with two rates of change, dr by dt and dV by dt, so those are the rates that are related to each other somehow in this problem. So there must be a relationship between dV by dt and dr by dt. That means that there must be a relationship between V and R. So do we know a relationship between V and R? Yeah, we do, right up here in the formula box. So the volume of a sphere is equal to 4 pi over 3 times the cube of R. So there's our relationship between V and R, which we will exploit so as to find a relationship between dV by dt and dr by dt. And again, we'll use the chain rule using Leibniz notation to do this. So using Leibniz notation for the chain rule, we have dV by dt will be equal to dV by dr times dr by dt. And again, you can, in your head, think that that works because the dr's cancel, leaving dV by dt, but remember that in reality, you can't cancel the dr's. It's just not something you can do. These are not actually fractions. They are rates of change. So you can't cancel numerator with denominator here. But it's a handy memory aid. Okay, so let's think about it. We're trying to find out the value of dV by dt. We're trying to find this out. We know the value of dr by dt. It's 4. And dV by dr we can figure out by doing the derivative of this guy up here. Okay, so that means that dV by dt is dV by dr, so that's 4 pi on 3 multiplied by 3r squared, and then we have dr by dt. Well, this simplifies quite nicely. We have, I'll just have to come up here, dV by dt. We have a 3 and a 3 that cancel, and we have left with us, we have 4 pi r squared times dr by dt. So there's our relationship between dV by dt and dr by dt, a bit simplified. I just thought I would highlight for you an interesting fact. 4 pi r squared is equal to the surface area of the cone, and that's just an interesting circumstance or interesting relationship between volume and surface area and rates of change. You'll notice a similar one when you differentiate the area of a circle. You'll get a similar result there, which is just interesting to note. Okay, so we're trying to find the value of dV by dt at t equals 5. So let's see if we know all the things we need to substitute in. We're going to need to know the value of r. Do we know the value of r? Well, not exactly, but we do know that the radius has been increasing at 4 millimeters per hour, and we know that 5 hours have passed. So that means that the radius must be 5 times 4 equals 20 millimeters at the moment in time that we're looking at the problem. And dr by dt we know is equal to 4 millimeters per hour. So if we substitute in, we get 4 pi multiplied by 20 squared multiplied by 4. And the units here are all millimeters and hours. So because this is working out to be dV by dt, this will be cubic millimeters per hour. And that works out to be equal to 6,400 times pi millimeters cubed per hour. And I think I'll just do a little simplification here because we might as well. We know that 10 millimeters is the same as 1 centimeter. And that means that 10 millimeters cubed must be the same as 1 centimeter cubed. And that means that 1,000 cubic millimeters is equal to 1 cubic centimeter. So since my answer is in millimeters cubed per hour, and I have a lot of them, 6,400 pi, I'm just going to shift the decimal point 3 places and call this 6.4 pi cubic centimeters per hour. And that's the rate of change of volume with respect to time at the 5-hour mark. You would want to write a therefore sentence if you're doing this for homework or on an assessment.